Our solar system is an extraordinary and diverse ecosystem, encompassing an incredible variety of planets, each with its own unique characteristics and geological histories. Beyond Earth, every planet tells part of the story of our system's evolution, and modern space missions are revolutionizing our understanding of these distant worlds. Moreover, through planetary exploration, we are learning about the formation of our solar system, the possibility of extraterrestrial life, and the conditions that might one day allow humanity to live beyond our planet. In this deep dive, we will explore each of the main planets, enriching our understanding with recent discoveries, future potential, and unresolved questions. Mercury, the first planet in the solar system, is subject to the Sun's gravitational and thermal forces more than any other celestial body. With a diameter of 4,880 km, Mercury is a small, rocky world without a significant atmosphere to shield it from solar radiation. Its position makes it the hottest planet during the day, but the lack of an atmosphere also results in frigid nights, with temperatures ranging from 180 degrees to 430 degrees. Despite its apparent hostility, scientists have discovered, thanks to data from the Messenger probe, that the planet has a surface rich in minerals and a core that is unusually large relative to its mass. Mercury also has a weak magnetic field, suggesting that its core might still be partially liquid. Recently, the joint ESA-JAXA mission Bepi-Colombo, which began exploring the planet in 2020, has provided new insights into Mercury's magnetic field and surface composition, including the presence of ice at its poles, shielded by extremely low temperatures. These findings raise new questions about the natural resources on Mercury's surface, which could have future applications in space exploration. Venus, Earth's twin planet, is similar in size to our planet but vastly different in conditions. Its surface is shrouded by thick clouds composed mainly of sulfuric acid, reflecting much of the sunlight and rendering it invisible to optical telescopes. Venus's atmosphere consists almost entirely of carbon dioxide, with dense sulfur clouds blocking sunlight but trapping heat in a greenhouse effect that pushes surface temperatures to lethal levels, around 465 degrees, hot enough to melt lead. Venus's atmosphere is also characterized by extremely strong winds exceeding 360 km/h, while its rotation is much slower than its orbit, resulting in a day on Venus being longer than a Venusian year. Recent missions, such as JAXA's Akatsuki probe, aim to better understand the meteorology and chemical composition of its atmosphere. One of the most intriguing questions is whether Venus might have had oceans and less hostile climatic conditions in the past. Ongoing research also explores the controversial and speculative possibility of microbial life in Venus's clouds. Earth is our only reference for life, and its uniqueness lies in the perfect combination of factors that allow living organisms to thrive. Our position in the habitable zone of the solar system, a region where liquid water can exist, is a critical factor for life on Earth. Additionally, the planet's diverse climates and environments, ranging from tropical forests to polar expanses and from seas to land masses, have fostered incredible biodiversity. Earth's atmosphere, primarily composed of oxygen and nitrogen, is essential for life and for protecting us from cosmic rays and solar radiation. Earth's gravity and magnetic field stabilize the climate and shield life from dangerous cosmic events, such as ultraviolet rays and solar particles. Furthermore, the presence of a natural satellite, the Moon, plays a significant role in stabilizing Earth's axial tilt, reducing the unpredictability of long-term climate changes. In recent decades, scientific research has increasingly focused on climate change and the impacts of human activities on the environment. The scientific community has highlighted the importance of conserving natural resources and reducing greenhouse gas emissions, particularly through initiatives such as the Paris Agreement on Climate Change. Additionally, exploring sustainable ways to support life on Earth, such as energy resource management and biodiversity protection, is crucial for the planet's future. Mars, the fourth planet in the solar system, has always captured scientific and popular interest. Its characteristic red color, due to iron oxides, hints at a fascinating geology, including massive volcanoes, valleys, and canyons, evidence of a geologically active past. Its thin atmosphere, composed mainly of carbon dioxide, cannot sustain life as we know it. However, Recent discoveries have revealed traces of salty water in brine flows along crater walls during warmer seasons, suggesting that Mars might have had conditions favorable to life in the distant past. Recent missions, such as the Perseverance rover and the InSight lander, aim to collect Martian soil samples and study its features, including signs of past life and the feasibility of future colonization. NASA and private companies like SpaceX have proposed ambitious plans to send astronauts to Mars by the 2030s, aiming to establish a permanent human colony on the planet. Mars is thus seen as one of the potential new frontiers for the expansion of human civilization. Jupiter, the gas giant of our solar system, has a diameter of about 139,800 kilometers, almost 11 times that of Earth. Its atmosphere consists primarily of hydrogen and helium, with traces of methane, ammonia, and water vapor giving the planet its distinctive horizontal bands. Jupiter is famous for the Great Red Spot, a storm that has raged for at least 350 years and could swallow Earth whole. Its magnetosphere is the largest in the solar system, 20,000 times stronger than Earth's. Probes like Juno and Galileo have provided detailed information about its composition, magnetic field, atmosphere, and moons. Jupiter has 79 known moons, including Ganymede, the largest in the solar system, and Europa, which has a subsurface ocean covered by an ice shell. Scientists believe this ocean could harbor microbial life, making it a key target for future missions such as NASA's Europa Clipper. The complexity and diversity of Jupiter, from its storms to its moons, make it a fertile field for scientific research. Saturn is renowned for its spectacular rings, composed of billions of ice and rock particles that brilliantly reflect sunlight. Its atmosphere is similar to Jupiter's, primarily hydrogen and helium, but Saturn is also known for its giant storms and flattened poles caused by its rapid rotation. Saturn has over 80 moons, some of which are of particular scientific interest. Titan, its largest moon, has a dense atmosphere and a surface covered with rivers and lakes of liquid methane, making it one of the world's most similar to Earth in physical features. The Cassini-Huygens mission, which orbited Saturn from 2004 to 2017, provided a wealth of data about the planet and its rings. The Huygens probe, which landed on Titan, revealed that this moon might have conditions capable of supporting life vastly different from that on Earth. Scientists are now analyzing these discoveries to better understand Titan's atmospheric dynamics and complex chemistry, which could offer clues about life's potential in extreme environments. Uranus, one of the least explored planets in the solar system, is an ice giant that intrigues scientists with its unique orientation. Rotating nearly completely on its side relative to its orbit, Uranus experiences extreme seasons and an unusual heat distribution that varies drastically between its summer and winter hemispheres. The planet consists mainly of hydrogen, helium, methane, and water, giving it its characteristic blue-green color. Observations from Earth-based telescopes and the Voyager 2 probe, which flew by Uranus in 1986, have provided some data about its atmosphere and magnetic field. However, Uranus remains a mystery, and its direct exploration is considered a long-term goal for future space missions. Scientists hope a deeper analysis of Uranus will reveal valuable insights into the dynamics of ice giants and the formation of the solar system. Neptune, the most distant planet from the Sun, is known for its stormy atmosphere and winds that can reach incredible speeds. Its atmosphere, primarily hydrogen and helium with significant methane, gives Neptune its blue appearance and hosts some of the solar system's most violent storms. Its moon Triton is unique for its retrograde orbit, suggesting it may have been captured by Neptune's gravity. The Voyager 2 probe is the only spacecraft to visit Neptune, but scientists continue to study it remotely using the Hubble Space Telescope to observe its atmosphere and moons. Neptune remains one of the most mysterious and fascinating frontiers of modern astronomy, and will likely be a focus of future exploration to better understand its atmospheric conditions and internal structure. Our solar system is a vast canvas of fascinating and complex worlds, each presenting unique challenges and mysteries. Advanced space missions and cutting-edge technologies are allowing us to explore these planets as never before. With every new discovery, we come closer to understanding not only how the planets formed, but also how they might evolve in the future, and what role they could play in humanity's expansion into the cosmos. Space exploration not only helps us understand the universe, but challenges us to rethink our place in it. Thank you for watching. Don't forget to like, subscribe, and hit the notification bell to stay updated on our next videos.